For decades, Pluto was seen as little more than a frozen leftover from the solar system's birth, distant, cold, and unremarkable. Once hailed as the ninth planet, it was reclassified as a dwarf planet in 2006, and for many, it seemed to fade into obscurity. But science has a way of reshaping our assumptions. New data, including observations from the James Webb Space Telescope, is forcing us to see Pluto in an entirely new light. Far from being a dead world, it now appears to be one of the most complex and intriguing objects in the outer solar system. At the center of this mystery lies Pluto's most famous landmark, the heart-shaped glacier known as Sputnik Planitia. Made largely of frozen nitrogen, it is so massive that it actually alters Pluto's balance and rotation. But the surface is only the beginning of the story. Beneath that icy crust, scientists suspect there may be a hidden ocean, liquid water preserved by heat from radioactive decay in Pluto's rocky core. If true, this would make Pluto not just an icy shell, but a layered world with an active interior. The possibility of a subsurface ocean immediately raises profound questions. Wherever water exists, the potential for life follows. Microbes on Earth thrive in places of darkness, pressure, and extreme cold, environments not unlike what might lie beneath Pluto's surface. If even the simplest life could survive there, it would revolutionize our understanding of habitability in the cosmos. Clues also come from Pluto's geology. Images from spacecraft revealed vast ridges, fractures, and plains, features that look more like a living, changing surface than a frozen fossil. Instead of being inert, Pluto shows signs of constant reshaping, driven by forces from within. Adding to the puzzle is its unusual relationship with its largest moon, Charon. The two bodies orbit a shared point in space, creating tidal forces that could stir Pluto's interior and keep that suspected ocean from freezing. Pluto's atmosphere adds another layer of intrigue. Thin, hazy, and laced with nitrogen and methane, it creates organic compounds called tholins, reddish substances that may be key ingredients in the chemistry of life. Charon itself seems to capture some of this material, forming mysterious red patches near its poles. Together, Pluto and Charon form a dynamic, interacting system unlike any other we've seen. Even stranger are the energy signatures and chemical patterns detected in recent years. Some resemble processes we associate with biology on Earth, though no conclusions can yet be drawn. It raises the unsettling possibility that Pluto's hidden ocean may not just be liquid, but alive, hosting forms of life unlike anything we've imagined. The story of Pluto stretches back to its violent beginnings. Born from collisions in the young solar system, it may have carried enough heat to melt ice inside, creating a long-lived ocean. Billions of years later, that ocean could still be there, kept warm by radioactive decay, tidal heating, or even magnetic forces we have yet to fully understand. In the end, Pluto refuses to fit into neat categories. It is not a barren rock, not a simple ball of ice, but a world of glaciers, shifting terrain, strange chemistry, and perhaps a hidden sea. It stands out in the Kuiper Belt, a region thought to be quiet and lifeless, yet Pluto shows us that activity and mystery thrive even at the edge of the sun's reach. Future missions will be essential if we are to truly understand Pluto. Orbiters could circle this distant world for months or even years, mapping every mountain, valley, and glacier in high resolution. They could track shifting ice sheets and monitor how the thin, hazy atmosphere changes with the seasons. Probes might one day dive directly into that atmosphere, sampling the exotic chemistry and revealing how Pluto's climate transforms as it slowly drifts along its 248-year orbit around the Sun. And perhaps the boldest dream of all, robotic landers could touch down on Pluto's frozen plains, not just to study the surface, but to drill deep into its icy crust. Beneath that ice may lie a liquid ocean, preserved for billions of years by heat from the rocky core. If such an ocean exists, it could hold answers to one of humanity's greatest questions. Can life exist in the most unlikely of places? Such missions would not only be daring, they would redefine exploration. They would allow us to look beneath Pluto's heart-shaped glacier, to peer into the very soul of this distant world, and to discover whether it is a barren shell, or a hidden cradle of biology. Until that day arrives, Pluto remains a symbol of the unknown. A world that was once written off as insignificant, downgraded from its planetary status, treated as little more than an icy leftover of the solar system's chaotic past. But Pluto has reclaimed its place in the spotlight. Far from forgotten, it now sits at the center of some of the deepest mysteries in planetary science. It reminds us that the solar system is not a finished book. It is a living story, and we have barely read the first chapters. And that is Pluto's true power. It forces us to rethink what makes a world worth studying. It is not size, grandeur, or proximity to the sun that matters. It is the mysteries hidden beneath the surface. Beneath Pluto's icy crust, under the faint shimmer of its reddish haze, and within the strange gravitational dance it shares with its moon Charon, lies a puzzle that challenges our understanding of geology, chemistry, and even biology. Perhaps Pluto's story is not one of loss but of rebirth. What was once dismissed as an inert ball of frozen nitrogen has become a frontier of possibility. A place that could reshape our definitions of habitability. A reminder that life may not only belong to warm, sunlit worlds, but also to dark, frozen realms kept alive by hidden oceans and internal fire. And this leads to a deeper, more haunting question. If Pluto, so distant, so overlooked, can astonish us with its complexity, what else is hiding in the shadows of the Kuiper Belt? That vast, frozen frontier beyond Neptune holds thousands of worlds, each with its own story, its own chemistry, and perhaps its own hidden seas. Could Eris, Makemake, or Sedna conceal oceans like Pluto's? Could the Kuiper Belt be more than a graveyard of ice? Could it be an archipelago of hidden, living worlds? The question is no longer whether Pluto is interesting. The real question is, what else lies waiting to be discovered? What hidden forces keep these distant bodies active? What strange chemistry unfolds in the cold twilight of the outer solar system? And most profoundly, is it possible that something is already alive out there, evolving in conditions so alien that we can hardly imagine them? Every step we take into the unknown reminds us of a simple truth. The universe is stranger, richer, and more surprising than we dare to believe. Pluto is proof of this. Once thought to be the end of the solar system's story, it is instead a new beginning. It is a frozen reminder that exploration is not about what we already know, but about what we cannot yet explain. The edge of the solar system is not a boundary. It is an invitation, a doorway to new questions, new mysteries, and perhaps, one day, new forms of life. Pluto is no longer a demoted planet. It is a beacon in the dark, calling us to keep going, to keep searching, and to never forget that the greatest discoveries are waiting in the places we least expect.